I want to start with a phrase that I guarantee every single person listening has either said or had screamed at them in frustration. It works on my machine.
The 5 most dangerous words in software development, yeah.
It is the classic defense, isn't it? You write some code, it runs perfectly on your laptop, you push it to the repository, and suddenly the production server is on fire.
Or your teammate can't even get it to compile.
Exactly, and you're sitting there thinking, well, I didn't break it.
But you did. Or, well, your environment did. And it's usually not because the logic of your code is wrong. It's because the whole ecosystem around that code is just fragile.
Right. Like, you're on Windows, they're on Linux.
Or you have a library installed that you just completely forgot to mention or commit. It's the environment dependency trap.
And that trap is exactly what we are dismantling today. We are looking at a set of notes from a computer science course, specifically CS326 Lab 2. But I want to be clear here. We aren't just walking through a homework assignment. We are using this lab to unpack the fundamental concepts that works on my machine chaos.
Yeah, this is about moving from just, writing scripts to actually engineering a build process. And for that, we're looking at 2 heroes of the Java world, Checkstyle and Apache Ant.
The enforcer and the builder.
Exactly. The mission here is to take a, quote, trivial Java program and build a robust infrastructure around it so that it is consistent, platform independent, and fully automated.
So let's start with the chaos of the code itself.
Okay.
Before we even try to compile anything, we have to talk about what the code actually looks like. The source material leads heavily with this tool called Checkstyle.
Ah, yes, the style police.
And honestly, this is the part where a lot of developers, they roll their eyes.
Oh, absolutely.
You think, why does the compiler care if I put my curly brace on a new line or the same line? Who cares if I use tabs or spaces?
And, technically you're right. The compiler doesn't care at all. The machine will process ugly code just as fast as pretty code.
But the humans won't.
Exactly. The source material makes a really important point here. Code is read by humans way more often than it is written by them.
That's such a great point.
If you and I are on the same project and your code formatting is all over the place, the cognitive load for me just to read your changes is massive. I'm spending brain power trying to figure out where a block ends, not what your code actually does.
It's just noise, and when you're debugging at 3 in the morning, that noise is excruciating.
It creates so much friction. So Checkstyle just enforces a standard. The notes mention things like the Sun Code conventions or the Google Java style. The whole idea is to stop humans from wasting time arguing about formatting.
You just outsource the nagging to the tool.
Precisely.
So how does Checkstyle actually know what to nag you about? It's not AI, right?
No, it's much more rigid than that. It uses configuration files. And in this era of Java, everything is about XML. Checkstyle uses these modules defined in an XML file. The source lists a few, like checker, treewalker, and javadoc method.
Treewalker is a fantastic name. It sounds like something from Dungeons and Dragons.
It does, doesn't it? But it's actually really descriptive. It literally walks the abstract syntax tree of your code.
Ah, okay.
So it's parsing the structure of the Java language itself to see if you broke the rules.
Did you comment that method? Is it that line longer than 80 characters?
So it's basically an automated grammar teacher. But here's what stood out to me in the notes. You shouldn't be running this manually.
God, no.
If you're typing a line, hitting enter, and then hitting the space bar 4 times, you were doing it wrong. The notes highlight the integration with Eclipse.
This is the productivity hack. You configure your IDE, your integrated development environment, to know the rules. The lab mentions a specific profile, D's Java formatting profile.
Okay.
Once you load that into Eclipse, you just hit the magic shortcut.
Control-Shift-F. The absolute lifesaver. You hit that, and Eclipse instantly snaps your messy code into perfect compliance with the profile. It fixes everything in a millisecond.
So the workflow isn't write messy code and get yelled at. It's write code however you want, hit the shortcut, and let the tool handle it.
Exactly. It removes the drudgery.
Yeah.
But, and this is a big but, in the lab, you can't rely on every developer remembering to hit that shortcut.
Trust but verify.
That's it. That's why the lab requires a check target in the build script. We're going to automate the policing so no illegal code ever makes it into the final build.
Okay, so we have clean formatted code. The style police are happy. Now we need to actually build it. Enter the ant.
Apache Ant.
And I have to ask, another neat tool, is that seriously the acronym?
It is. It was the year 2000. Naming conventions were a bit more whimsical back then.
It feels a little cute for something this industrial,
It does, but its origin is pure utility. It started as part of the Apache Tomcat project. And the developers needed a reliable way to build Tomcat across different operating systems.
And that's the killer feature, isn't it? Platform independence.
That is the core philosophy. Before Ant, you might write a shell script. But a shell script is tied to the OS. A Linux script uses forward slashes. A Windows batch file uses backslashes. It just breaks.
So Ant is the universal translator.
Exactly. Ant is written in Java. So anywhere the Java virtual machine works, Ant works. It abstracts away the operating system.
The other big idea in the notes is decoupling the build from the IDE. We just praised Eclipse, but now the notes are saying don't require Eclipse to build.
It's a crucial distinction. The IDE is for editing. Ant is for building. I shouldn't have to install your specific IDE and import your project just to compile your code. I should be able to type Ant compile in any terminal and get a result.
That makes the project so much more resilient. The knowledge of how to build the software isn't locked inside one person's laptop settings.
It's codified. The truth of the build lives in one file, build.xml. That file is the brain of the whole operation.
So let's dissect this brain. The lab notes break down the structure into projects, targets, and tasks.
Right. Think of it like a recipe. The project is the whole dish. The targets are the big steps: prep, cook, serve. And the tasks are the specific actions. Chop the onion, boil the water.
Okay, but before you start chopping, you need your ingredients. In Ant, these seem to be the properties.
Yep, properties are your variables. The number one rule is don't repeat yourself. You don't want to hard code the name of your JAR file in 20 different places.
Because you'll definitely miss one when you have to change it.
You always do. So you define it once, like property name, proj.jar value, KYN. Then you reference it with proj.jar.
But there's a power user feature mentioned called the command line override. Thought this was really cool.
The -D flag. This is huge for testing. Let's say your build.xml sets the version to 1.0, but you want to test a 2.0 build without editing the file. You just run ant-d version 2.0. The command line overrides the file.
It's like a manual override switch on a machine.
It is. It gives you so much flexibility.
Now, that leads us to maybe the trickiest part of this lab, and honestly, of Java in general, class paths.
Dependency hell.
The notes are very specific here. They talk about using path and file set. I do love file set because you can just say .jar and grab everything.
It's very powerful. But we have to flag a major constraint from the source material. This is where students usually trip up. It has to do with the Linux lab computers.
The dreaded disk space quota.
The classic university lab problem.
Yeah.
Students have limited disk space. JAR files can be big. If you have 30 students all copying the same 50 megs of libraries into their home directories, you're just wasting gigabytes of server space.
So the rule is, do not copy the libraries into your project.
Exactly. The lab explicitly forbids it. Instead, you have to reference a shared location. The path is given as Students' Home CS Courses JavaLib.
So this forces you to understand how Ant handles external paths. You can't just assume everything is in a local lib folder.
Right. And you also have to tell your IDE about that path, or Eclipse will just show red squiggly lines everywhere.
But here's the trap, right? If I hard code that weird server path into my build.xml, the build script is no longer portable. It won't run on my laptop.
That's the trap. And the solution is the build.properties file. You define a property, let's call it lib.dir. On the lab machine, the build.properties file says lib.dir students home cs courses.dir build. On your laptop, you have a different build.properties that says lib.dir see my libs.
So the build.xml just says, go look at lib. It doesn't care where that actually points.
Exactly. The logic stays the same, only the configuration changes. That's proper engineering.
Oh, we've got our properties. Now let's talk workflow, the targets. This is where Ant feels so different from a simple script because of dependencies.
The dependency chain. It's basically a domino effect.
Walk us through that.
Okay, so you want to run the program. That's your goal. But you can't run it if you haven't compiled it.
Right.
And you can't compile it if you haven't created the directory for the compiled files, your bin folder.
So you tell Ant about these relationships.
Yeah. You define target run depends on compile, and target compile depends on init.
So if I just type Ant run, what happens?
Ant is smart. It walks backward. It says, okay, to run, I need compile. And to compile, I need init. So it executes init first, then compile, then finally run.
You don't have to micromanage the order. That's clever.
You just declare the relationships. And you could even have conditional targets. The notes mention if and unless. So you could have a target that only runs if a property like is.production.build is set.
Let's get into the worker bees, the tasks themselves. These are the XML tags that actually do stuff.
The verbs of the build script.
First up, mkdir and delete.
Standard housekeeping, mkdir is for your init target to create folders. Delete is for your clean target to wipe them out.
The notes flag and attribute for delete include empty dirs. True.
Yeah, that's important. Sometimes delete will remove the files but leave the empty folder structure behind. This just ensures you nuke the whole thing.
Next, stamp.
Timestamp. It just creates variables with the current date and time. Use it to tag your builds, maybe name a file backup 2026-129.zip. It's crucial for versioning.
Now the big one, javac.
The heart of the build. You give a scarger and a destert. But there's a subtle attribute mentioned that I love. Deprecation. Yes.
Why would we want more warnings?
Because they're good warnings. Java evolves. Methods get deprecated, which is code for we're going to remove this in a future version, so stop using it. If you don't turn that flag on, the compiler stays silent. This keeps your code future-proof.
And javac is efficient, right? It doesn't rebuild everything every time.
That's the other huge win. Ant checks timestamps.
Yeah.
If the Java file hasn't changed since that class file was made and just skips it, on a huge project, that saves hours.
Then we have Java to run the program. And the notes practically scream about one attribute, fork true.
Yes. This is non-negotiable.
Fork, like a fork in the road.
Exactly. It means run this program in a separate Java virtual machine.
Okay, why does that matter so much?
So, and itself is a Java program running in a JVM. If you don't fork, it runs your program inside that same JVM. They're sharing memory.
I see where this is going.
Right. Your program has a bug. Maybe calls system.exit, or it has an infinite loop that eats all the memory.
And if they're in the same JVM?
Your program kills Ant. The whole build process just crashes and vanishes. No error report, no cleanup, nothing.
That's a nightmare.
By setting fork true, Ant spins up a new separate JVM just for your program. It watches from a safe distance. If your program crashes, Ant is still alive to report the failure. It's a sandbox.
That makes perfect sense. And finally, jar.
Yep. Packages it all up into a Java archive. The notes mention the manifest file, which is how you make the JArr executable, so a user can just double-click it.
Okay, let's bring this all home for the listener doing Lab 2. The source provides a very specific execution plan. Step 1 is getting to code.
Git workflow. The command is git clone username at bits.muned.com.cs326 individual lab work, and then git pull to get the lab 2 CS326 and demo app folder.
And your job isn't to touch the Java code, it's to engineer that build.xml.
That's right.
So let's run down the required targets. This is the checklist. Target 1.clean.
Has to delete bin, docs, and errors. Remember, include empty dirs.
Target 2.init.
Recreates those same directories. Simple enough.
Target 3.compile.
Okay, this depends on init. It compiles SRC into bin, but there's a gotcha here.
The resource files?
The non-Java files. Well, JavaC only looks at .java files. If you have a config file or an image, you have to explicitly add a copy task to move those into your bin folder too.
A very common failure point. Target 4.run.
Depends on compile. And remember, fork, true.
Target 5.doc.
Generates the Java doc. The requirement here is that it must include private methods. You have to add a flag for that.
And target 6.check.
That's our Checkstyle integration. Runs the formatter verification we talked about at the very beginning.
And throughout all of this, what is the golden rule?
Do not hard code the class path. Use the property that points to that shared lab directory. If you hard code a local path, it will fail when the professor grades it on the server.
It's a pretty comprehensive exercise. I mean, we've gone from messy manual compilation to this fully structured assembly line.
It's a huge transformation. You stop being just a coder and you start being a software engineer. You're building a system that lets other people collaborate with you.
Right. That standardization is what enables teamwork. It doesn't matter if I'm on Linux and you're on Windows. If the build.xml is right, the project just works.
It democratizes the whole development environment.
You know, there was a quote in the source that stuck with me. It says, Ant allows new applications to be developed with minimal time put into source arrangement.
Right, because it imposes a structure.
But it makes me wonder if the tool dictates where the files go and how they're named and how they're built. Does the tool serve the developer, or does the developer end up serving the tool?
That's the eternal engineering question, isn't it? We shape our tools, and then our tools shape us. By accepting the constraints of a build tool, you do lose some freedom. You can't just put files wherever you feel like anymore.
But what do you gain in return?
You gain scalability.
Reliability.
You gain the ability to work in a team of hundreds without stepping on each other's toes. So in a way, you submit to the XML overlords for the greater good of the project.
A philosophical thought to mull over while you are debugging your XML tags. Go forth, fork your processes, and tame that code.
Happy building.
We'll see you in the next deep dive.